Hello and welcome to another one of these ADD videos. Today we're going to be talking about the relationships that become apparent whenever you're dealing with a constant acceleration in physics. The first of which we're going to deal with is velocity. Velocity would be equal to the initial velocity plus acceleration times time. So that's whether we're dealing with the velocity in the y direction, this initial y, plus acceleration in y, which is usually gravity, times time, or if we're dealing with velocity in the oops, just did y. That's what happens when you're doing videos late night. Velocity of the x also has that same relationship. Okay. The next group of equations have to do with distance. This basic relationship will be the change in distance, actually, will be equal to the initial velocity times time plus 1/2 the acceleration times time squared. Okay, so again, same concept. We're dealing with delta x, which would be x2 minus x1. That's the final minus initial. We have this symbol delta here. That would be equal to v naught x t plus 1/2 a and you can also have, again, the change in y. And these equations are mainly dealing with the fact that they are one-dimensional travel. They can be dealt with in two-dimensional travel as well, such as projection problems, or projectile motion problems. I think I'm falling asleep. This might be my last video for the evening. So if that is the case, then we would be breaking up the velocity, for instance, into its components using your good old trigonometry skills. Done by the same type of logic. And then you could adjust the equations for the angle. Okay? A couple more equations we should look into. First of which is going to be the relation of velocity, acceleration, and distance. So this one's going to be this velocity squared is equal to the initial velocity squared plus twice the acceleration times the distance. So if it's one-dimensional in the x, oops, I'm using red here, shouldn't I? Just stick to the definitely in the last video. Or if it's in Y, okay? And the last one of these equations that I'm going to look at today is going to be distance change and distance defeating the change will be equal to the average of your initial and actual velocity. Times time. This should actually go on the outside there. Okay, so if it's delta x, again x2 minus x1, oops. I think I'm going to re-record this video at some point, all the little mistakes I'm making. But the average of the initial, actual, times time, or okay? So these equations will kind of be like puzzle pieces, and you will just need to ask yourself, what do I have, what do I want, and how can I get to what I want from what I have. Usually you will have to use certain conceptual facts and adjacent. Wow, I really do need to record this. You will have to use conceptual facts in conjunction with these equations to determine when is initial velocity equal to 0, or when is acceleration equal to 0, and just solve it like a puzzle. The more you practice these, the more they will become apparent. I suggest that you do make your coordinate system true to real life. That way it doesn't confuse you when you get an answer. So, in other words, positive y direction be up, and negative y direction down, and negative x direction left, positive x direction is to the right. Later on, when we do free body diagrams, we will be arbitrarily moving around our axes. But for now, let's try to keep them as the real number system is the Cartesian plane. Thank you. I hope this helped, and make sure you check out our example videos.